Good afternoon. I'm Alon. I work at SAP IT, and I'm going to talk about continuous delivery process that we implemented in our team. So let's start. First of all, a couple of words about SAP. It's a 40 years old company, leader in enterprise applications, 70,000 employees and 180,000 customers worldwide. So quite a big company. I'm part of the social collaboration platform team, which is part of SAP IT. So we don't build the products that SAP sells eventually to their customers, but we build the products that SAP customers, employees, and their partners are using. So for example, we're building something called the Help Portal, which is a website that combines all of SAP product documentation. And another example is the SAP Community Network. It's a collaboration website that contains forums and blog and different blogs and contains 2 million registered users. So quite a big thing. I'm specifically responsible for the search topic in the team. And our goal basically is to provide one-stop place for searching SAP-related content. So we're talking about continuous delivery here. So little numbers, we're managing only for that project around 100 machines, some of them physical, most of them are virtual, and 40 of them are in productive deployments. And we are already implementing continuous delivery over 2 years now. So I'm going to talk today about this journey that we traveled back starting from 2 years until today, implementing that. So first let's concentrate on the problems that we had before we switched to continuous delivery and all the new tools and processes of working. So the first problem that we had, and I already explained that we are doing multiple projects, some of them are shorter and some of them are longer, is the physical hardware that we were relying on and the manual setup. And the problem with physical hardware and the manual setup of this hardware is eventually time. It can take 3 months to order the hardware for a new project, and it takes time to set up the operating system and all the infrastructure, all the different runtimes that the specific application uses. Then the next problem is the manual deployment. So it's a classical DevOps problem that you have silos, you have the development team, you have the operations team, and the development team builds applications, and the operations team deploy them to the productive system, and somebody needs to explain, the development team needs to explain the operations team how the application is configured, how the application is deployed, and it's done with the long manuals, and these manuals need to be updated and need to be maintained all the time, and it's error prone because it's very hard to apply the same configuration on different nodes over and over again, and these two things together, the physical hardware, the manual setup, and the manual deployment, not only very time consuming, but also it brings us to a point where it's very difficult to create similar environments. So every environment that people are creating is a little bit different, and something works for you in QA and then it doesn't work in production, and you start to look on which node the configuration wasn't applied in the correct order or in the correct wherever it is. So these two things are more on the operations side, and then the next two problems are more related to the development process that we had. So we had a waterfall-like long development process around 3 months of development cycles, which were following manual QA, manual regression tests that could be up to 2 weeks in some cases, and of course this is not optimal. The QA team doesn't really like to do these regression tests over and over again, and time consuming, and again error prone, because people are not very good at repeating the same tasks over and over again. So yes, all of these problems are kind of connected together, and we've been thinking very hard about all the waste that we have in our process, and starting from the development and to the QA and to the different layers that we had in our infrastructure and application, and how to solve them. And back at that time, our chief architect read the book Continuous Delivery by Jez and David, and he was very excited because the ideas in this book were really solving a lot of our problems. and we decided to start a journey to implement some of them. So let's see how we implement these different problems, and later on I will discuss also the tools that we chose to implement and how we use these tools in our team. So first we move to virtualization instead of physical hardware and infrastructure automation, and only that already improved by a big factor our ability to bring up new applications, because you basically save all the time that you needed to wait for the hardware, and you saved all the time that you needed to wait for the manual setup of the runtimes and the middleware and the databases and whatever you're using. We implemented deployment automation, so it's just a click of a button, you can deploy any application to your stack, and you don't have to wait. And these two things not only saved a lot of time from our team, but it also created a possibility to bring up environments which are similar to one to another. And it was very easy to create an environment, for example, for load test, execute your load test, which might take 1 week, and then just release the hardware the virtual hardware that you're using. And it's just, you can do it fast without an effort, and then it speeds up everything. We also implemented test automation, end-to-end functional tests that simulate what the end users are actually doing with the application. So we save a lot of efforts on the QA team, and when you look at these 3 building blocks, you understand that these are the main building blocks that you need to be able to implement continuous delivery. Because the moment you can create environments and deploy the latest application to your environment from scratch, and the moment you don't really invest a lot of power in that, you will do it very often, and you will also be able to test this new environment that you just created without an effort. And this is basically continuous delivery, to be able to continuously install your latest version and test and make sure that it works. So our continuous delivery process is kind of built on top of these building blocks.
So you're kind of being humble with that, but you're saying first we implemented virtualization and infrastructure automation, big task, right?
Okay, so
then we implemented deployment automation, another big task. Then you probably had to teach your people, or find ways that to relax the concerns of what happens if this doesn't work, what happens if automation isn't correct. So I guess in those 4 circuits that look pretty nice on the screen, you had to invest quite a lot of effort.
Yeah, so this is a continuous effort, and also the order of the things that you see now on the screen is just a logical order. We didn't really do it by that particular order, so we didn't invest only in virtualization and infrastructure automation, and when we've done with that, we invested in deployment and QA. It took us 2 years, and I will explain the evolution of the things a little bit as much as I have time. But you're right, it's a big effort, it's a lot of investment. Everybody needs to understand when this kind of a big shifting from a company that is doing, classical software development, when you're relying on long development cycles and manual QA and all these things that people used to do, and you want to basically switch all over to the new philosophy of doing things, and you're right, it's a lot of effort.
And I think that what's interesting in this case is that unlike previous cases that were discussed, such as Wix, Tatango, Outbrain, and a few other companies, SAP has 70,000 employees, has a lot of cash going in and out. So this is not something that's done lightly.
Okay, so a good point. Maybe I needed to explain first that this is something that we implemented solely inside our team, which is around 100, 150 employees if we count also the operations team. And it's not all of SAP, not all of SAP implementing this right now, but actually this platform that we built and the tools that we've built on top of that were very successful, and now they are being adopted by other teams, and maybe in the future some of these practices will be even proposed to SAP customers. So we're now in the process of a big success with this process, and we are expanding. So
right, and it's important to realize that this is happening in SAP. It's not in Facebook.
Yeah.
It's not in Google. It's in SAP.
It's happening in SAP.
It's a different story, I think.
You're right. Okay, so let's look at the tools that we choose to implement the different aspects. So for virtualization, when we say the word virtualization, people think right about Amazon and Rackspace. SAP, of course, relies solely on services that it operates by itself. So we have an internal private cloud with VMware software. So we use that for infrastructure automation. We're using Chef, open source framework with very big community. I think Ron in his talk said that the strongest point of Chef is its huge community. So anything you would really need to install, probably somebody already automated that. That of course except the tools that SAP itself, products that SAP itself uses, and we use a lot of SAP products, so we had to automate them. And we're using GitHub Enterprise as our source control that stores not only the application source code, but also all the Chef automation scripts and also our infrastructure as code, which is basically the definition files that describe our environments, which machine we have in the environments, and how these machines are set up. So everything is stored in GitHub Enterprise, which is the same product that runs at github.com, but you basically can buy it and install it inside your network. Then for the deployment automation, we use Chef. Again, it's the same tool that we use for the infrastructure automation. And Ron explained the differences between infrastructure automation and the deployment automation. We use Chef quite successfully to deploy our application. So we have one stack, one solution for everything. We are using Chef maybe not in a very common way, so we're not running it unattended. Usually people are, by default, Chef runs every half an hour, something like that on the machines to bring your infrastructure up to date with your automation. But we are using Chef as part of our deployment pipeline, which we will see later in the talk. And when we coordinate a Chef run on all the nodes, we're basically also updating the infrastructure to the latest version of our automation. We're also deploying the application. Then for the QA automation, where we have basically our application is exposing the RESTful APIs, which are wrapped with different Java libraries on top of that, and we have a web UI. So the web UI is automated with Selenium, and all the APIs are automated with the JUnit and the different libraries that are written on top. And the overall continuous delivery, which is basically connecting and orchestrating all these components together, is implemented with Atlassian Bamboo, which is continuous integration server, one of the best in the market. And we will see a little bit how the pipeline is implemented. So let's dive a little bit into how we use our infrastructure automation. We'll start with the virtualization. So we had a couple of evolutions with how we use the virtualization layer. We started with the VMware just by using its web applications and its tools that are coming with the VMware itself, and that was already a big step forward for us because we could create an environment that we needed just by a couple of clicks on the web UI. But that, of course, not optimal. So we later we found out that there are APIs exposed, and there are tools that on the command line that you can automate around, and you create different configuration scripts that will create your environments on demand. So we switched to that, and today we have we moved even a step forward when we implement fully something called infrastructure as code philosophy, where you have the configuration files that describes your environment and describes your the machines that you have in every environment and what automation should be executed on these machines. And then there is a tool that reads these configuration files and creates the environment for you and install it and installs everything that needs to be there for you. So an example for a configuration file might look something like that. On the top you see a Chef repository. Chef repository is a Git repository where all of your automation scripts are located that will be needed for creating a specific environment. And then you have the name of the environment, in this case it's production, and then you have a list of servers, and for each server you have a run list. The run list is coming from the Chef terminology. It's basically the list of the scripts that you want to execute on a node when you install it. And of course you can also say things like which operating system template you are using for the specific node, and how many CPUs you have, how much memory, and things like that. This is stripped off file, but you can control almost every aspect of your application through this configuration file. Then let's talk about a little bit how we use Chef. So we basically, what we have is each project that we run have its own chef repository that contains the automation scripts that are were specifically written for this specific application, and the scripts know the internals of our application, how the configuration files look like, how the database schema look like, how the different database migration should be executed, how the application should be deployed. And on top of that, we have shared automation or shared cookbooks. The cookbook is basically the chef packaging, where you package different automation scripts. So we have a list of shared automation scripts that are have their own Git repositories, and that because we need to share components like, I don't know, MySQL and JVM between the different projects. So we don't want to have to write them over and over again. And we're using an open source library that is called Librarian Chef to bundle together the different automation parts that we have in the company, and to create one bundled chef repository that is used to install a system. So it looks like this. We have different source repositories. We use Librarian and Git client to combine them up into one automation repository, and then that is uploaded to the Chef server. I didn't explain maybe a couple of words about how Chef is working. So Chef has two versions. We're using the more complex version, which is the Chef server. There is also Chef Solo, which you can use if you want to install specific nodes without big complications. But if you have complex environments and you have a system that has different nodes, and you need to know about the topology of your network, and you want to be able to ask questions when you're installing a node, like if you're installing an application server, you need to know what is the IP address of the database server. So you need a central component that contains all this information about the whole environment, and that product is the Chef server that manages also your all the nodes that you have in the environment, and also you are uploading your Chef repository automation scripts into it. And once you upload these scripts, then you can execute Chef client. Chef client is a piece of software that you install on all the nodes, and when you run the Chef client on a different node that you want to install, they are communicating to the Chef server to download the automation pieces that they need to execute on themselves, and then they run them. So this is how we use Chef. This is an example of a Librarian Chef configuration file. Again, the Librarian is the piece that bundles together the different automation scripts. And once you are starting to work with Chef, and you rely a lot on Chef, you start to see, it's like managing your code. You need to have different dependencies, and you have different repositories where the code is located. So Librarian Chef solves the problem of dependency management and the cookbook management. And the configuration file looks like this. You have something in the upper part of the file that's called site, which points basically to a location where all of your cookbooks, all of your automation pieces are exposed via API, and you can look up for the different pieces of automation. And you can say just I use cookbook Tomcat, and then that line will download the Tomcat automation script from the specific Git repository, and it will also download all the dependencies that the Tomcat cookbook is using. So it's very useful. So we talked about 4 different components. We talked about the virtualization layer, we talked about Chef, we talked about Git, we talked about Librarian. All of these components are they are passive. They're not doing anything by themselves. Somebody needs to tell them, please create a virtual machine, please install a Chef server, please synchronize the Git repository into the Chef server. So we wrote basically an internal tool that is called the Barkeeper, which connects all these components together. So it reads the configuration file that we saw earlier that describes the environment, and it creates the virtual machines needed. It creates the virtual machine and installs on it the Chef server, and installs on all the nodes the Chef client, and it handles also things like permissions, so you can describe who can log into a specific machine and who can log into a specific environment. And it has a UI and REST API and a command line interface, so you can automate on top of that. And it's very useful because this is exactly what we use in our continuous delivery pipeline. So in our continuous delivery pipeline, we are communicating with the command line interface to bring up entire environments from scratch, to install the latest version on them, testing is not part of that. We'll see later. But basically, everything that is connected to the infrastructure automation is done through this API, through this system. And this is an example to a screen that we have in Barkeeper. It's just the same screen that we saw earlier in the configuration file. So you see all the servers in a specific environment here. What is the state of the servers, if they're up and running or not. And you can see different actions that you can execute on the different nodes. Okay, deployment automation. So I said that we're using Chef. Every application that we have, we are writing a specific Chef automation script that knows how to deploy this application, know how to create the database schema if we have, know how to do different database migrations and to generate the configuration files and all these things. And all of that is, again, done with Chef. Then the QA piece. We implemented end-to-end functional acceptance tests, and this is very important. This is actually the most important thing, in my opinion, in continuous delivery, because if you want to be able to deploy your application, often you need to be able to know that your application is working as expected and you didn't break anything with the code change or configuration change. So in my opinion, end-to-end functional tests and acceptance tests are the key point in implementing continuous delivery. The more you invest in it and the more you have of that, you will be able to rely on that, that your changes are not breaking anything. And what Ron asked earlier, it was really a big effort to create this test automation. We had also to do application adaptations to be able to create this automation. And usually how it's supposed to be done is that you start with your most important functionality that you have in the application, you automate that. And once you have that, you already saved quite a lot of things that you don't want to do every time you change your application, testing this 20% of your most important functionality, and then little by little you add more and more. So we have around 80% of our functionality implemented, and this is why we still have some manual QA done before the deployment, and also because we have some complex integration with third-party systems that we don't own, so we cannot really test this piece automatically. So let's talk about continuous delivery. I already said that we're using Atlassian Bamboo, and Atlassian Bamboo is orchestrating for us all the flow from the point in time where we are updating the source control repository until where this change is deployed to the different environments, QA, production, and other. So we're using Bamboo supports, of course, build grids, and build grids are actually very important because you want to be able to execute your deployment pipeline as fast as you can. And the moment that you have complex system with a lot of tests that you need to execute, it might be very time consuming. So you want to be able to scale also with your application. Once the application gets complicated, you want to be able to execute things in parallel. Also, you want to do deployment in parallel, you want to do test in parallel, and that is why very important to have a build system that is scalable.
How long do you just run right now?
Today it's about 1 hour. So from the...
Parallel?
Yeah. It's after we did a lot of things to bring this down. In the beginning it was much more, but today we're doing things like compilation. For example, our UI is built with GWT, and GWT has a long compilation periods. So we divided our application into smaller parts, so we can execute the compilation in parallel, but the compilation is only the small part. Also, I think the majority of the time that it takes is the test automation, because to test all the different, we start, I will talk about this later, but we start basically with an empty environment that was just deployed right now. It doesn't have any data in it, so we generate test data, we fill up the database with this data, and then we execute all the different end-user scenarios on it. So this is the thing that is that takes the majority of the time, but I think 1 hour is much better than what we had in the beginning, where we had 2 weeks of QA.
So I think one of the main things that make that slow is I/O of any kind, whether it be database, file system, or networking. And the next question is, do developers run the tests before they commit? And if they do, what parts of the test can they or do they run?
Okay, it's a very good question. We are trying to do as much as possible to be able to have all the test automation also easy to write and also easy to execute. But not everything we can execute on the developer's machine. We have a concept that is called the private bar. A private bar is something that every developer can create a set of virtual machines that are defined through the configurations file that we see, and these virtual machines will create a mini environment for the developer. And in case the developer really changes something complex that he needs the whole full environment with all the services, he can always create a private bar and to install his version of the application that is changed to the private bar before committing it and to execute all the tests against it. Of course, not everybody are doing it. It's only in some cases when you want to test all the stack before you're committing. Usually you're doing something small, so you can run JUnits locally, but you know.
Yeah. So I think you may find this useful to even give up a few tests, but make the whole suite a lot faster, such that every developer can run all the tests before commit. And I think you might find this better than adding more automation but not having everyone running.
Okay. I accept that. It just because we rely so much on automation, we specifically created this feature private bar because the moment you invest so much in automation, you will not be able to have your local development systems always up to date with everything that is done in the development environment, because it's not always possible to run Chef the way you run it on your cloud, on your local machines.
Yeah.
So this is
I
the...
completely understand. I mean, the feature of private bar sounds very useful. I mean, it's very useful to be able to replicate the production environment locally. Definitely this is useful. I'm also saying that there's no replacement for having fast tests. Fast tests is super important, in my opinion.
I agree. Okay, so this is how our continuous delivery pipeline looks like. It's pretty generic, I think, so let's go over the things. On the left side, in the green color, you have the jobs themselves that do the actual promotion of the thing. So you start with the first two blocks: build, unit test, package, and publish. They are triggered the moment a developer or an operations guy changes something in the source control. And that compiles and executes unit test, packages everything, and publishes the artifacts to the binary repository. The binary repository is a place where we store all of our artifacts, and also we store all of our third-party binaries that we use to install the different infrastructures that we use. Once the commit stage is finished, we are moving to the third stage, and this is the most important one. It's the deploy test environment and the functional tests. So this is basically executing or calling Barkeeper to create an environment to deploy all the infrastructures that we need to be in that environment and to deploy the application, and then runs the functional test on this newly born environment. And you see the arrows from the test environment to the source repository and to the binary repositories, because this process of the deployment is actually using the test automation, which is located in the source control, and it is using the binaries, the application binaries and the third-party binaries that we are using to deploy the application. Once all the tests are passing, we are promoting the build to the next environment, QA, and we are potentially can also, after we have the QA approval, we promote it to production. So I want to explain a little bit deeper. The third part, the deploy test, is actually, we can divide it into three different parts. The first part, we call it the environment initialization. This is where we are booting up the different VMs in the configuration that we need them. Then the second phase is the environment installation. This is where we are running Chef Client on the nodes to install the infrastructure that we are using to deploy the application latest version, to do the database migration in case it's needed. And then the last stage is executing the test automation. So the first stage looks like this. Actually, to be able to speed up the process of this specific stage, booting up VMs is something that is quite expensive. It can take up to 10 minutes in specific cases. So this is something that we are not doing in the main pipeline. This is something we still want to test, bringing up new environments from scratch. and being able to know that this process works perfectly. But in the main pipeline, what we do is we are upgrading an existing environment. So this is the same thing that happens in production, because you will usually not install your production from scratch. So you want to test both use cases when you are upgrading a system and you're also installing it from scratch. And to upgrade the system is much faster than creating it. So again, it looks like this. The barkeeper is reading from the Git repository the configuration of the virtual machines, and it creates these machines with addition to the chef infrastructure that we are using to install it. Then we are in the stage of installing environment, and all of these things happens on the behalf of Bamboo. So the Bamboo pipeline is asking the build grid, the build agents to execute chef client runs on the different VMs. But before this, what we are doing is we are syncing the chef server with the latest automation scripts. And you see that the build grid is the same color as the environment that we are installing, and that's very important because we are installing the build grid with the same infrastructure, with chef and the same automation techniques that we are installing the real environment to be able to scale it out. And this is what we said in the beginning. And the last thing is that we are running the automation test in parallel, so you will not be able to always execute everything in parallel, but you have some cases where you have some test cases that rely on other test cases to finish first. But always you need to think about parallel execution and to execute as much as possible of the test automation, and not only test automation, anything that you run in the pipeline in parallel. And the more you can execute in parallel, the better you will be able to scale out your process later. So this is it. How did we get there in 2 years? So this is what Ron asked in the beginning. It was really tough 2 years when we started from nearly nothing until this nice, fully automated process where we removed the majority of the waste that we had in the team. And the key is that this is an evolution and not a revolution. It takes a lot of time and a lot of iterations to find the exact or the perfect solution for the different problems that you have. So constantly rethink and to improve, and constantly give technical talks and encourage hands-on and document everything. So the whole team, the operations team, the development team, the management, everybody understands what we are doing, why we are doing that. And the moment people are also doing and touching new technology and the new tools with their own hands, this is the most important thing, because this is the only way you can bring the knowledge to everybody, and this is the way you will be able to scale your evolutions further. Also, it's important to make the tools easy for everyone to use. In our case, it's still not very easy. You need to know a lot of things before you can even start using this process. So not everybody today know how to add a new machine to specific existing environment, because you need to know Git, you need to understand how the configuration files look like, you need to be able to test everything in a lower environment. So the simpler the tools will be, it will be better for you.
How much time does it take for a new developer?
It depends on the level of the developer, it's
in average. Is it in like
it's hard to say.
Days, weeks, months?
It can be 1 week if somebody who knows the concepts, Only learn Git, only if you're coming from a world and you never used Git before, only learning Git, it can be a couple of days just to know the basics of Git, It's complex, all these things.
2 years ago, before you started this, you probably had more people doing it.
Okay, it's a good point. Actually, it's a good point. We have the same amount of operations people, but today, development team and the operations team are responsible for the system altogether. We don't have this responsibility anymore. So everybody are doing everything. Everybody are able to connect to the productive system and to look into the log and to find out what is the problem. And that is very important because from our experience, what happened the moment we had this responsibility, and we came to this responsibility not by deciding that, but actually that happened to us because when we were ready to bring this technology to the productive system, and we did it, not everybody in the operations team, and of course not everybody in the development team, were able to use these tools already, as we expected. So what happened is that the people who knew how to use the tools started to be responsible for the productive system, and then little by little, more and more people came and learned the tools. And
Did you write the tools along with the operations folks?
no. The operation.
If you've done this, would you work?
We tried, but we did it over a period of time when all the time we had a running business where we had the development going on, applications were in production, things were eventually upgraded. So
everyone does. So,
yeah.
But I'm just saying. I'm just asking if you've done this again, would you do this?
We tried.
Another way, or would you do something else another way?
I think the only way that it was possible in our case to do it is how we did it, and we did try to have the operation guys writing chef automation, and today this is what we have. Today actually we have very good operation guys who write chef automation.
Are those the same people that used to work 2 years ago?
Yeah, it's the same people. It was not easy. It was not easy to convince, but in my next slide. I have a line that says if you build it, they will come. What happens that once people see how much better the new process is, people will want to start writing the automation because they will see how much time it saves. They will see that they don't need to do this manual configuration that they've been doing for years, and now everything is much better, and they don't need to do boring stuff anymore. A question?
You said you have an upgrade scenario, or is it starting to do the VM? And the upgrade scenario, how do you manage the database migration?
Okay, so the database migration are just done with SQL. So if I need to add to an existing table a new column, for example, so we just write an SQL script that checks if this column is already there. If not, we just alter the table. So every scenario is a little bit different. If we need to do data. If the automatic test fails, sorry? We're always moving forward. So if we update database schema and we have a test that is relying on a specific database schema and we forget to update the test, it fails, and then we need to update the test. There was a question there?
Some similar question you asked before. If you would done same process today, what could you shorten in the way to make it 1 year or even less?
We didn't have a problem. We didn't have a program to have it for the period of 2 years. We just identified the biggest pain points that we had in the process, and we thought about the solutions that we would like to have, and this was our goal. And we moved gradually and eventually to bring ourselves to this point. It's very difficult. This is a very big and large scale change that an organization is doing. And I think it's very hard to plan and to make a work progress and say in 2 months from now we will be here. Also because you are doing it with your regular work and your regular operations. But I think what we could to make it shorter, I don't know.
So if you could focus a couple of minutes that you still have on the culture aspects. I mean, what was easy to do, what was difficult to do,
okay.
How did people accept it?
So this is exactly the next slide, I think. A change of mind. So I think the biggest change of mind, in my opinion, is the change of mind in the developer's eyes. So the developer suddenly is not responsible only for the lines of code that he's writing. He suddenly needs to understand in automation, he needs to understand how the deployment to the application server is done, he needs to understand how the database works, how the database is installed, and all these things. They need to invest a lot of efforts into test automation, something that not all of the developers are accustomed to do.
So were developers happy with that new responsibility?
In the beginning, no. In the beginning, it's maybe a better thing to talk about if the developers were happy or not is the feature toggles. Okay, so when you're doing continuous delivery, you are usually not working with the bunches anymore. You are working always on the trunk, and the people are continuously every day committing their code change to the trunk, even if the feature that they are working on is not finished yet. And it was very hard to convince the developers, to not to work with branches anymore, because it's actually a lot more work to maintain these feature toggles. Because once you work with the feature toggles and you have big features, it's not only in one place that you need to write this if. And afterwards, you need to remove this if, because if you don't remove the if, little by little, you will have a spaghetti code. You will have one feature inside another feature and a lot of ifs. And it's much more work for the developers instead of working with features, and it doesn't look really, logical for them. And we had a team leader that was really opposing that kind of work in the beginning. But then after 2 sprints, 2-3 sprints, people understand that it's really much better. It's just magic.
It's easier than that.
It's easier than magic. Exactly.
Okay, but so what was at the end? I mean, so developers were kind of upset that now they have this new responsibility. Now they
It's
have
not the upset. You didn't. Developers always want to understand why. Why is it better? So, and it's quite. It's not that.
This get resolved. I mean,
It got resolved that we said, okay, we had specific with this team leader. We had a lot of discussions. We tried to explain. We asked him to read all these references by different people who talked about that. And eventually, the whole team was into that already. And after a couple of sprints, again, you have to do it with your own hands to understand it. You cannot really figure out why it's better before you do it. It's just unacceptable. For people who work 10 years in software development with branches, it's hard to understand. Yes.
I have 2 questions. First of all, are you managing your infrastructure by yourself? And you're showing that you're connecting to your server, deploy new machines, and install them. So, meaning that you have infrastructure as a service, seamless, no problem with it.
Yeah, there is a different team.
We have, after this, we have time for one more question, and then we're going to have to move on. Go on.
So yeah, there is a different team in SAP that manages the infrastructure itself. So we're not touching that. All the.
Okay, and the second question was triggering your next step in deployment. For example, if you're a QA person, let's say accepted the test and want to promote your binary, for example, for the next step.
It's automated, but you have a button that somebody needs to press on the deployment pipeline. So when the QA team approves a deployment to production and the business approves it, so somebody just presses the button, and then the same thing that happens on the test environment when the continuous integration server runs Chef client on all the different nodes, and before that it synchronizes all the automation to the correct version to the Chef server. All these things happen on the productive environment. The same thing that happened. Who's pressing the button? Anybody can press the button. It depends on when we are doing the deployment. Sometimes if it's Sunday, so we are also a distributed team. Some people are located in Germany, some people are located in Israel. If it's a deployment that needs to be done on Sunday, usually it's on Sunday, I can do it, or somebody else from the Israeli team can do it. If it's something that is done on Friday, then somebody from the operations team does it. It depends. But really the key here that everybody, there's no such a thing that only operations can do. Anybody can do it. It's just the mutual responsibility for the productive system by everybody.
Okay, thank you. Sorry you don't have enough time.